All right. So we can get started here. Let me hit Slack up on my phone as usual. Da-da-da. Okay, cool. So, as usual, feel free to pop a question into Slack if you're curious about anything. If you have a question regarding the Learn material, feel free to put it in there. If the problem you're working on has a link, obviously in the Learn material, it will have a link to Learn. Or if it's from somewhere else, please provide the link so I can go verify what it is. If you're just working on something on your own and you just have like a problem or something that you're working through, yeah, you just need me to troubleshoot your code or something, I can do that as well. But if the problem has a link, then please provide that so I can have a metric to test it against. And yeah, feel free to just put that in there when you're ready. We'll go from there. Right now I don't see any questions posted, so we can just go through the material. So last time we got a little bit through the breaking loops section. So we were talking about breaking loops, and it looks like I did one of the challenges, but I'm not sure which one. Okay, well, do I need to reload this page or something? What's going on? Okay. Yeah, so I'll just go through the challenges for the breaking loops section, and we'll just go from there. So the idea with breaking loops is it allows us to, the break keyword allows us to stop a loop prematurely before it would stop naturally, or in the case of a while loop, to prevent an infinite loop under certain circumstances. So yeah. So let's do this function, complete the contains even function, which checks if a given list of integers contains any even numbers. Do not iterate over the entire list if possible, right? So we could do this. We could say, let's do this, has evens equals, let's say true, or let's actually start it at false. And then we can do for num in list if num mod 2. So if num over 2 has a remainder equal to 0, if num over 2 doesn't have a remainder, or it has a remainder of 0, then we know 2 is a factor of num, so we know num is even. So we can just we can set has evens to true, and then break, and then return has evens, just the variable, just whatever the value it is. And that's correct. Let's look at the suggested solution. Looks like it's the same solution. They just called their variable something different. So let's go back up here. If we think about this, there's actually kind of an easier way of doing this. We could set this Boolean flag, check the condition, and break accordingly. Or we can use return as a de facto break. And in this case, that's what I would do. So I would just return true here, else, or not else, but after we get all the way through the loop, notice, I don't know why I said else, that's kind of misleading. So this is not an else in alternative to this if, it's just after the loop we can return false. And then we don't even need this Boolean flag. We can just get rid of that. So what this is going to do is it's going to go for num and numless, check every number, see if there's any even numbers, and if it finds an even number, it's just going to return true. Since return stops code execution in a function, if this condition is true, then this return line will be executed. And that will stop right in the middle of the loop. So it's a de facto, in this context, it's a de facto break. If you have return in a condition in a loop, it will break the loop. And then if we make it all the way through the loop without returning true, then we can just return false. Pretty easy. So let's try that, and this should pass as well. Cool. Complete the sum is too large, or sum too large function, which checks if the sum of a given list of numbers is larger than that threshold. So this takes in, or I don't know why I said that, larger than a threshold. So this function takes in a list and then some integer for the, or some number for the threshold. Similar sort of thing here, if, or excuse me, for num in list, if, well, we have to take the sum. So we'll do total equals 0, total plus equals num, if total is greater than, is it going to check greater than or equal, okay, whether the sum of the list is greater than, so just greater than, not greater than or equal. So if total is greater than thresh, that's our thresh parameter here that we're going to check. So if total is greater than thresh, we can return true. And if we make it all the way through the loop, we'll return false. Okay, cool. So this will work as is, although I default to using return in this case, just returning as soon as I know what I need to return. I should probably use break though, because that's the point of this lesson. So let's say too large equals, do we want to do false? Yeah. And then I can do too large equals true here and break. Okay, so that'll work the same. So just to be clear, this will work without the break. But we want the break that way, you know, if the threshold is 4 and the first number we check is 10, then we know right away that we don't need to check any of the other numbers, right? Because the total, the sum is already larger than that first number. So the break just saves us extra looping. Cool. And it looks like I've done this one before. Find primes. This one's kind of fun, I think. Am I remembering this one? So find all the prime numbers in nums and return those primes. Okay. I'm going to see real quick. I'm just going to pop this in. We'll reset the input here. Reset the input. Complete the function according to its doc string. Okay, so find primes. Finds all the prime numbers in nums and returns those primes in a new list. So given a list of numbers containing some primes, so I'll call this my list equals okay, so let's go through this. So 5 is a prime, 7 is a prime, 6, 8, 2 is a prime, 3 is a prime. Let's just put 11 in there. I don't know. 11. Okay. And then we'll throw some edge cases just to verify that it'll work for edge cases. So this is the list I expect returned for this input. So if I say print find primes of my list, we should expect this list here. Okay. Okay, so I'm just going to do an accumulator list equals empty list for num and nums. If num, we want to see if it's prime. So if is prime num. Now is prime is a function that I got to write. So let's go write that and verify it. So let's just print out num, and we'll just use this as our test for is prime right now. Okay, cool. So we'll say def is prime, takes in, and we can think about this. If we check every number up to n, not including n or 1. We don't want to include 1. So if we start at 2 and check every number from 2 up to n, if any of those numbers, if n is divisible by any of those numbers, then it will be not prime. So for I in range 2 to n. Now I don't need to go all the way to n because factors of a number come in pairs, right? And they're never more than half, right? You can never have, like, there's no scenario where any number has a factor that is greater than half of that number, a whole number factor, right? You could have like a decimal number that divides into something greater than half, but a whole number factor, right? So, and the smallest number is 2, of course. Or, well, the smallest factor is 1, but 1 is a factor of every number, including a prime number. So real quick here. So we don't need to go all the way up to n. We can actually just go through half of n. And in this case, we would want to include that. So half of n plus 1. So that'll make it inclusive. We can actually optimize this even further by doing the square root of n. So n to the 1/2 is the square root of n. plus 1 is going to include it in the range. So that's the minimum set of numbers that we need to check in order to determine if a number is prime or not. There are even other optimizations, but I'll kind of leave those out. So we'll check numbers from 2 to the square root of n. What about if n is less than 2? So if n is less than 2, we're just going to say it's not a prime number. So if n less than 2, return false. And yeah, now we can go back down to our primary logic. So if at any point n mod I equals 0, so the remainder of n over I is 0, we will return false. And I just remembered, again, we're supposed to be using break here. I'm going to write it this way because I think it's a better way to write it. And then we'll look at the break way, and hopefully it'll be clear why I prefer this way. So if we make it all the way through, checking every number in that range without it returning false and stopping the execution, we can just return true. Cool. So let's test it out. I said I'd let the find primes function be my test for is prime, but I'm actually going to test it differently because, I don't know, it feels right to do that. So for I in range, let's just do range 20. We'll check every number from 0 to 19 this way and print I is prime I. And this will show us I and whether or not true or false, whether or not I is prime. Float object cannot be interpreted as an integer. Okay, I forgot I need to make, since I'm using this 1 over 2, I need to make that into an integer explicitly. Okay, so 0 and 1 is false. 2 and 3 are prime. 4 is not prime. 5 is prime. 6 is not prime. 7 is prime. 8, 9, and 10 are not prime. 11 and 13 are prime. 14, 15, 16 are not prime. 17 is prime. 18 is not prime, and 19 is prime. Good. So that looks correct to me. Okay, so back to the find primes. So all we need to do is just iterate through, I mean, essentially this function is akin to the test that I just wrote and deleted. You know, it's essentially doing this, except instead of checking a range, it's checking some list from the input, right? So in this case, find primes in my list. Let's just run this and print all the numbers. We'll see if only prime numbers get printed. 5, 7, 2, 3, and 11. Cool. Now all that's left to do is append these to our list, return our list. Return list, and list.append num, and we should be good. So much lag on this computer. Okay. I've had a few people ask me about this problem recently. Oh, and I need to show the break solution as well, sorry. But I've had a few people ask me about this problem in the past couple months. And I think the big trick here is this question's a lot easier if you write is prime in its own function. You can do this, you can absolutely do this in one function, although, you know, this is prime function isn't terribly complicated. And then this function is like pretty much bone simple, but if you combine them, it starts to kind of feel like there's a lot going on. Let's look at that too. But first, let me show the break solution. So the break solution, or really the Boolean flag solution, let's say prime equals true, and then wherever I'm returning false, I'll say prime equals false, and then down here I'll just return prime. The return that was here on line 9 was breaking the loop, so I should probably add a break so I can recuperate that breaking behavior to stop the loop early. So this should work as well. And then as for this, we can't throw a break in here. That doesn't make as much sense. So yeah. Okay. So as for combining these, we kind of do need to use this Boolean flag style solution. So let's do this. So for num in nums, we'll say prime equals true, and I'm just going to put these comment bars in here so we can be clear about where the code is that I pasted in. So this is the code from the isPrime function. So prime equals true if n is less than 2, prime is false. Yeah, so if n is less than 2, prime is false. And then we can just use if prime like this. And then let's just check this. For I in range 2 to int, this should be num, to the square root plus 1, so that includes square root. If num mod n, actually, I don't know, I like n better. I'm going to use n here. So for n in nums, yeah, so then for I in range, if n mod I equals 0, prime equals false, and break. Now, bit of a question arises here because notice we have a nested loop in this case, right? So we have, here's our outer loop, and here's our inner loop. Here's our inner loop. So the question is, since break stops a loop, does it break this loop, or the outer loop, or all the loops, or only one loop? Which loop does it break, or does it break multiples? And the answer is it just breaks the loop that it is most immediately inside of. So it is most immediately inside of this inner loop, therefore it's going to break the inner loop. So let's just run this, make sure it still works. We're error free. Num append n. There we go. Had that num floating around in there. And let me just annotate this. So this break acts on the inner loop there. Okay, cool. So 5, 7, 2, 3, 11. 5, 7, 2, 3, 11 is our expectation. Good. And let's just verify it. So let's just juxtapose these really quickly. So here's my isPrime function. It's not so bad. Here's my findPrimes function. Well, given that if I have the isPrime function, this is really easy. But here's the combination of the two, and I end up with one function that does both things. And it's not terribly complicated, but it's sort of getting, it's sort of getting a little, it's growing, you know. It's getting a bit bigger. So this starts to feel like it's kind of getting into complicated territory. If I write something with a nested loop, I'm always thinking like, do I need to do that? And if I do, quite often it makes more sense to write all of this logic is the is prime function. So quite often it makes sense at least to break that into its own function, if not try to get rid of the inner loop altogether, which in this case we can't. Or if we can, I don't know how, but yeah, so let's submit this solution and verify that it does work, prove that it does work. We'll do that. Cool. But I like that solution better. So much lag. And let's see what they did. So they have this other kind of is prime function, looks like. Yeah. This is a Boolean flag style is prime. They have some slightly different control flow for the edge cases up here, but other than that, and the comments, it's pretty much the same as the Boolean flag style function. And then this is just the combination combined with the find primes function. It's nice and easy. Oops. Okay. So skipping loops. On to continue here. Let's see. All right. So skipping loops. So continue is similar to break, but instead of just stopping the loop totally, it's just going to skip to the next iteration. I think he can make the argument that it would have made more sense to use the word skip instead of continue. But they use the word continue, so that's continue it is. But if it helps, I think it helped me when I was learning to just. I remember sort of having a breakthrough, like, oh, when I see continue, I'm just going to think skip, like skip to the next loop. So here you'll use continue to separate squares from non-squares. You could easily write this another way without using continue, but this will demonstrate the functionality of continue. So. So this is sort of another variation. I mean, this is kind of a variation on the problem that we just did. I'm actually going to show this. I'll show this with the problem that we just did. You can kind of look at that code and hopefully you'll be able to see the similarity what I'm talking about here. And I'm going to convert this back to my preferred way, find prime. So this will just be return false. This will be return. And this will be true. Okay. Then this will be is prime n, and we can get rid of all this. Nice and easy. Okay. So we could do this, like we could filter out non-primes like this. We could say, or yeah, so if the number is not prime, we want to continue. If we don't continue, then we're going to make it to this append line. If this condition is true, if not is prime in is true, then we're going to run the continue, and that means that after this point in this iteration, no more code is executed in this loop. It's going to stop executing code for that loop and just move, or not for the whole loop, but for that iteration of the loop, and it's just going to move on to the next iteration. Yeah. So this should append prime numbers as well. Oops, and may actually copy the tests as well. Cool. 572.3.11, 572.3.11. Good. That works. So this would be using continue to skip numbers that aren't prime. And then that way you only append numbers that are prime. And you might ask, like, why not do things this way? And then not do the like weird negative thing, like if number is prime, then append it. Yeah, I mean, in this case, I think that makes more sense to just do that. It's nice and easy. Okay. Why does it say we're in skipping loops? Break challenge? Break challenge? Continue challenge. Interesting. Okay, so let's just do these challenges anyways. So complete the sum only evens function, which takes a list of numbers and adds those which are even. Try to remember that the point of this challenge is to use the continue keyword. Okay, I'll try. So for num in list, if num mod 2 equals 1, so it's if num mod 2 equals 1, it's odd. If num mod 2 is 1, then we'll continue. And then we can total plus equals num. So I'll call this total equals 0. Return total. Bingo. Okay. So that's with continue. Personally, I do think it makes more sense to do this, but hey. Same diff. Or actually, no, it's a different diff, but there we go. We'll do that one. Okay, picky prod. Multiplies only numbers that are divisible by 3 or 7. A parameter is a list of numbers to multiply. Numbers returns number, which is an int or a float, the product of the numbers in the list that are multiples of 3 or 7. Okay, cool. So we only want to multiply numbers that are multiples of 3 or 7. So if num mod 3 equals 0, or num mod 7 equals 0. So that's going to be kind of the heart of this pass. We need num, so let's do for num in list. There we go. And I guess we could do not equals here. Not equals here. And then again, we could do continue. And prod equals 1. Prod times equals num. I like n. I'm going to use n. Nope. Okay. And then return prod. So after the loop, we return prod. And we'll see. Oh, nope, nope, didn't like that. 1 is not equal to 376,000. Well, how about that, huh? Okay. I think I'm going to do it my way. Equals. Let's try that. No, it still didn't work. But I did get a different answer, which is very interesting. Okay. Okay, so multiply only numbers that are, that are not divisible. Okay. So if I just had this all kind of backwards. Okay. Well, there we go. There we go. Okay, that works. So if we continue under this circumstance, or we could just do the simple way again. It's simple if you actually read the whole problem statement, unlike me. Okay, cool. So if the num mod 3 not equal to 0. Oh no. Oh no. What is this? What? This has to be and. Okay. All right. Yeah, so that's I guess an alternative, but let's do it the way they asked for because that was the way they asked for it. Cool. All right. Which numbers will be printed while running the code block below? So we have for I in range 20, if I squared, you know what? If I squared greater than or equal to 64, okay, so that's going to be 8 or more. 5, 6, 7. And then if I squared less than 144, so it'll be 7 and then start with 13. We should start at 0 up to 7, start at 13 up to 19. So I think it'll be that first one. These other ones are wrong because they're not starting in the right place. Cool. Passing over conditions. Okay. This might need to be overhauled a little bit because we don't. So break and continue apply to loops only. Their only application is inside of loops. It doesn't have to be just for loops. I only gave examples with for loops. They will work on while loops as well. honestly, you probably use them more often with while loops. At least break you use with while loops more often, because while loops have a tendency to run forever if you don't tell them to stop. So, especially if you write them like I do, which is with a while true. So they require manual breaking essentially. So I use break and while loops all the time, whereas it's more rare for me to use break in a for loop. And I would say I use continue about in proportion to how often I write either for or while loops. I write more for loops. Most of the problems I'm working with I can solve with for loops. And every now and again I need to use continue. Every now and again in while loops I need to use continue as well. Pass has nothing to do with loops though. Pass, well, nothing to do with loops like break and continue have to do. So break and continue bear on loops and nothing else. Their only job is to be sort of give us more control over our looping. Pass's job is to it's valid code. It's basically a placeholder. It's valid code that doesn't do anything. It literally does nothing. It has no logical impact on your code whatsoever. I've only ever seen it used as a placeholder, except other than for maybe just a couple of things. The only time where I've seen it as like a permanent fixture of code is in error handling, where if you catch an error that you specify, you try to do something and you specify a given error to throw an exception on, then you can pass in that except block, and it just doesn't do anything. And sometimes in error handling, you say, well, if I get this special error, then I just want to ignore it. And yeah, there's a reason that we don't cover error handling in prep though. We're dealing with a lot of beginner students, and I think there's a tendency for people to want to write code that is error avoidant, and error handling kind of can get you into hot water with like avoiding too many errors. Generally, you want to write your code in such a way that it doesn't produce errors, rather than writing code that does produce errors that you just systematically ignore. You don't want to ignore errors habitually. You want to ignore them purposefully. There are some cases where it makes sense to just be like, well, if I get this error, I don't care. We can just move on with the code. So that's the only scenario that I know of where pass is like used as a permanent fixture in your code. That's not like a placeholder for something that you're going to come back to later. So that's the only place that I'm aware of pass being used as like a permanent part of your code. So it might seem like, well, what's the big deal? Like, who cares? Whatever. Why would we need a placeholder? Why wouldn't you just finish the code? I mean, you'll see me use it if you watch study halls, or if you're watching me code in premium prep, or if you have a one-on-one with me, you see me code and you'll see me use it. You'll see people use it, and it's like you get 10 lines into something or more, and you start kind of juggling ideas around, and you're trying to write really fast because you've got an idea and you're trying to chase it down. You're like, I'm going to edit this up here and I'm going to need this condition, but you don't want to finish the condition right now. You just know which condition you need, and you're going to come back to what you're going to do in that condition later. You can throw a pass in it, and then it'll keep it valid, right? Yeah, so an example would be, let's say def is prime. Is prime will take in n, and if I'm writing some other function that I wanna work on the logic of that function, I'll come back and write is prime. Later, I can throw pass in here, and it'll just be a placeholder, and it won't do anything. So the reason that this is necessary, you might say, well, why not just not put anything in there, just leave it alone, right? So def is prime like this. So this is going to give us a syntax error. This is not valid Python syntax. So this says unexpected end of file. EOF is short for end of file while parsing, and it kind of gives me the last line before the end of file there. So that means the file ended before it thought it should, right? So when Python sees a line of code that ends in a colon like this, that colon says, well, whatever this is asking for a body of code. So this is a function head. This asks for a body of code. If I don't give it one, Python's not just going to be like, oh, okay, well, I see that you don't want to put anything in there right now. It's going to be like, it's going to freak out and throw an error and not know what to do. So we have to explicitly tell it, hey, don't worry about it, pass. Just placeholder, get back to that later. Same is true with if is prime. I don't know, 10. Pass. So if we don't want to put anything in the condition right now, pass. If we want to write a loop for I in range 10, but we don't want to fill in the contents of the body of the loop, we can pass. So that is what pass's job is it's a placeholder. It is valid code that does nothing. And Python needs valid code in these kinds of places. So it looks like we do have a question here. And let me copy this link and go to challenge 3. Oof. Okay. Okay, there's a comma there. Well, let's do this. I copied that comma from the question. Oops. Okay, tuples are immutable. Oof, we got a 2-space indent here. I'll need to fix that. Let me just actually, no, I'll have to go back and fix that later. And this is number 2. Let's go to number 3 here. Okay. So write a function called tuple creating tuple. Let's do that in here. Speaking of pass, I'll come back to that. And I know I'm going to want to test this with something. Print, I'm not sure what I want the inputs to be. Okay, so this function takes 3 arguments called name tup, age tup, and job tup. Okay, the 3 tuples are in parallel. So let's do this. Oops. And we'll make these tuples. So I'm going to call this names, ages, and jobs. Okay. So names are going to be Clark and Joanne and Billy Bob Thornton. And then ages are going to be 479, 25, and 999. And then jobs are going to be astronaut, super astronaut, AUGHT. Okay, I think that's how you spell. That's probably not how you spell astronaut. Okay, apologies. And Baker. Okay, so names. Let's do this. I'll be super lazy, nice and lazy. Okay. Where were we? So this function takes 3 arguments called names, name tup, age tup, and job tup. The 3 tuples are in parallel since they contain the same number of items, and each item at a given index corresponds to the other item in the given index. Okay, cool. So just for context, all that's saying is the items correspond across their indices. Oops. So this says Clark is 479 years old and is an astronaut. Joanne is 25 years old and is a super astronaut. Billy Bob Thornton is 999 and is a baker. Okay. And let's see. Each item given corresponds. Okay, that's all that's saying. Index across. Okay. That's just giving an example of parallelization, which is what I just talked about. This function should return a single tuple where all of the values given at an index are the data of the same person. Okay, cool. So let's see. This function should return a single tuple where all of the values at a given index are tuples. So it'll be a tuple of tuples. Okay, cool. So tup equals tuple, and we can for name, age, job in zip. We can just zip our inputs straight away, just like that. And we'll say tup plus equals tup of these 3 things inside a tup with that in it, and we'll return tup. Okay, so this is the analog of an append to a tuple, right? So we're this is actually a concatenation, remember? So this is syntactic sugar for tup equals tup plus this. So it's the current value of tup, which at first is empty, plus a tuple containing this tuple. Notice the comma at the end. This outer tuple is a single element tuple. A tuple with a single element in it requires a comma at the end so that Python knows that it's a tuple, not a not a what am I saying here? Not an expression group. Cool. Okay, let's run that. Oh no. Okay. Oh, that's why. I'm like, wait, what happened? So first of all, I didn't delete the other line, and then second, I'm appending the or adding in concatenating the entire tuple rather than just the single elements. I was like, well, that went terribly wrong. Okay, cool. So there's that. Let's submit it. Correct. Cool. Now, let's see. This doesn't actually have an example given. Let's see here. So since there's no suggested solution, yeah, I'm just thinking, like, this is kind of the way for adding tuples. This is my preferred. Honestly, I really like to write code like this. I really like tuple accumulators. Being that they're immutable, they're really safe. You're not going to change data where you don't, in an unexpected way in general. They end up being pretty fast and efficient as well. I'm just trying to think if there's like a easier analog for this. So we could use a list, and then list dot append a tuple, just this name age job tuple like this, and just return tuple list like that. So that would be an alternate way with the same effect. I'm sure it'll get past the tests here at least, but you know, that is another way. Oh, will I paste the code in Slack? Yeah, I'll pop that into Slack for sure. Let me back it up here. There we go. Just run that real quick. Yeah, we'll do that. And then we have some code provided. It says I was trying to use concatenation but not correctly. This is what I had. So I'll take a look at this and we'll see what this solution is about. Okay, cool. Ah, I see. Yeah. I see. Yeah, so one thing you could do is do for I in range since we're assuming, since the problem explicitly says that these are going to be the same len, we can just use the length of any of these and do I in range one of those. And then just say, we could say tup equals that, and then we can do tup sub I like that, and res equals a tuple, and then res plus equals tup. Let's just call this outer tup, and let's call this inner tup. Okay, outer tup and inner tup. Okay, so you could do things this way. Similarly, at least. The only difference is, so this is, I see what you're thinking about. You're thinking about like string concatenation. So the reason we do this with strings is obviously just to add in spaces into the string. But concatenation, the term just refers to when we use a plus operator, essentially when we add, quote unquote, add something, some collection of things to another collection of things. So a string to a string, or a list to a list, or a tuple to a tuple to a tuple. I think you can. I'm not sure. Can you concatenate sets? No, you can't concatenate sets. But yeah, in this case, so here's the concatenation. Concatenation, right? And this takes the place. This takes the place of append in this particular case. So for this, you can just do comma separated values, and that will actually be a tuple or a tuple. I don't know why I'm saying tuple. I think some people say tuple. Evidently, I say both under random circumstances. So yeah, you were really close there. Yeah, just the. I think the problem would have been, I should have actually ran that. Let me actually run that and see what error we're going to get. But it should say something about like can't concatenate tuple to string or something like that. It would be a type error, I think. Yep. Can only concatenate string, not int to string. Well, right, because this is an integer, right? Yeah, that makes sense. Oh, okay, well, I don't know why that happened. Oops, and then we want to return. Come on. This computer is extremely slow. Okay. Oops. We need to do that. We need to nest it so that it stays as a tuple. Otherwise, it'll just be, yeah. Okay, there you go. So that's a working solution. Will I paste that version too? Yes. Oh my gosh, did I forget to, no, I paste the other version? Oh, I did paste the other version. Okay. I'll paste them, nope, I'll paste just one. Friday. There we go. Cool. All right, well, Yeah, you're welcome. Let me know if you have any other questions about this or about another one. I'm not seeing any other questions at the moment, so yeah, maybe we'll just continue on. I really like tuples, so I don't know. Let's go over tuples. Tuples are immutable, declared with parentheses. Similarities to lists are that they're essentially, you can think about them as a collection of arbitrary objects. A list truly is a collection of objects. A tuple is a collection of pointers to objects. So a tuple doesn't literally contain any values like a list does. Not that that's very important in the grand, in the grand scheme of, well, it's important in the grand scheme of things, but in the immediate scheme of things, when you're just trying to use it, it's often not that important to know. But yeah, so they're similar to lists. They're basically like immutable lists. If you took away all the mutable behavior, mutable methods, and other mutable behavior from lists, you'd end up with a tuple, basically. That's one way to think about it, at least. We can index, we can slice. And the indexing and slicing and concatenation rules work exactly like they do with lists. All right, so let's look at these other ones. What will be printed to the console when the following code block executes? We have tuple of a list of ABC. Example tuple sub 0 dot append D. So tuple sub 0 is that list, so that will append to that list. So this is sort of an exception to tuple immutability, where if a tuple contains an object that is mutable, that object is still mutable. So we can mutate mutable objects inside of tuples. So that'll be right there. Oops. Are these the same? What would be printed? I think it'll be this, because is it really going to include that comma? I don't think the interpreter includes the comma. I think you just have to include that. All right, I might be wrong. I'll find out. I'll eat those words if I have to. All right, words eaten. I was wrong. So that's interesting. I thought that the interpreter would exclude that comma for a single element tuple when it prints it out, but that you needed to put it in when you're writing it in your code. But evidently, it's the case on either end. So yeah, I evidently forgot about that. All right, I stand corrected. Then this one, we've got this two-space indent here. Oh, a tragedy. Two-space indent. There we go. I'm going to go in and fix that after this. Try to get rid of all the two-space indent stuff. Okay, so complete the function called insert at index 2. Okay, this takes a tuple called tup and an int called x. This function should return a tup where x is in the tuple at the second index. Okay. So we can return tup sub colon colon, oops, those aren't colons. We want to start at the beginning and go up to, but not including index 2, plus a tuple containing x, single element tuple, plus tuple starting from index 2 on to the end. Cool. If you were feeling cheeky, you could say list equals list of tuple, and you could say list dot insert to x return tuple list. And then you're cheating, but nobody will know. So that's a way to use lists to do this, and just cast this tuple as a list, and then cast the list back as a do your mutable operation on your list, and then cast it back as a tuple. You could do it that way too. I like this way though. I don't know. Fits on a line. Uses slicing. Slicing is cool. All the cool kids are slicing these days. Ah, that sounds weird. All right, I don't know what kids are doing these days. I'm gonna stop hypothesizing about that. Okay. Sets. Oh, right. We're we're over here. We were talking about pass. In your own words, describe when you would use break, continue, and pass. Break and continue are for loops. They allow us finer control over looping. Pass, whereas pass has nothing. It's nothing to do with loops. Okay, whereas passes use is mostly, almost always, as a placeholder for parts of code, of your code. We'll say parts of code that require a body that you're not providing at the moment. Okay. Okay. I managed to spell whereas. Functions, loops, conditions, and classes, amongst other constructs in Python. Let's do this. Pass can apply to functions, loops, conditions, and classes amongst other constructs in Python. Cool. All right. We'll do that. All right. While loops overview. So let's kind of get into the intro of this, and then we'll probably wrap up. So while loops are just, sometimes they're called conditional loops. because they are controlled by a condition, and in one way or the other. You're going to see me when I give examples of while loops. I like to do this thing where I write while true like this. This is like, as I say, kind of putting a where true, while true. Okay. Um, this is, as I sometimes say, like throwing a brick on your gas pedal. You know, it's just going to go forever until you tell it to stop, until you break it. So that's while true. Yeah, so we don't have to put true here, though. We can put any condition, any expression that'll evaluate to true or false. Think about it like an if statement. It's exactly like an if right here, right? So we have if and then condition, right? And then here is the same thing. Condition, while condition. Quite often I combine the two like this, where I'll say, sometimes I'll put a condition in here and check another condition and break, or just while true and break. And this might look the same, like, you know, you could put your condition in an if, um, or you could check your condition in the while. But the condition that you have to check if you do a while true and an if is the opposite condition that you check if you just do a while condition. So I generally find this easier to think about, easier to write. Yeah, there's sort of just an ease to this way of doing things, so that's why I prefer it. Oops, I don't need this pass here anymore, but yeah. So yeah, so so that's sort of the synopsis on while loops. The use case is, well, they do have a potential danger of getting into infinite loops. It's easy to write a while loop that gets into an infinite loop on accident, whereas it's sort of harder to write a for loop that gets into an infinite loop on accident. Yeah, so the use case for while loops is that they are better suited for solving certain problems than while loops are. So, or excuse me, than for loops are. So for loops are easier to use, but their use case is a little narrower than while loops. We can use a while loop to solve any problem that we could solve with a for loop. And sometimes it's nice to have that sort of finer level of control that a while loop gives us. But sometimes it's, if you can get away with using a for loop, you definitely should. So anyways, we're close to our normal stopping time, so I think I'll wrap up there. But yeah, hopefully this was useful. Thanks to the person who asked a question. It's good having some question today. So yeah, appreciate that, and I'll see you all next time. I'll be streaming on Monday, so I'll see you then. Cool. Bye bye.